Hi, welcome to our very first junior number video. In this video, we're going to chat about some key things about the number topic, and it might be useful for you to pause the video as you go and take some notes if you need to. Right, we start with counting numbers. Counting numbers are numbers that we count with, and we always count starting with 1. So counting numbers start at 1, they're whole numbers 1, 2, 3, 4, 5, and they continue on forever. Sometimes we refer to them as the natural numbers. Right, whole numbers. Whole numbers are also counting numbers, but include 0. So if we start at 0, we don't start counting at 0. That's why they're not counting numbers, but whole numbers start at 0 and go 0, 1, 2, 3, 4, 5, and so on. Right, what about integers? Integers are whole numbers, but also include negative whole numbers, as well as the number 0. So here is our number line that demonstrate what integers are. They're whole numbers like 0, 1, 2, 3, 4, 5 and continue to the right in the positive direction, but they also go to the left in the negative direction. So they go -1, -2, -3 and so on. So numbers to the right of 0 are called positive numbers, and numbers to the left of 0 are called negative numbers. Right, a rational number. Rational number is a number that can be written as a fraction. Here are some examples of rational numbers. -7 is rational because it can be written as a fraction of -7 divided by 1. Any number divided by 1 is itself, by the way. 8 is also rational because I can write it as 8 divided by 1. 8 divided by 1 is just 8, which is a rational number because it can be written as a fraction. Now, the number 1.5, a decimal, is halfway between 1 and 2. I can write it as this fraction, 3 over 2. 3 divided by 2 is equal to 1.5, and therefore it's a rational number. And finally, 4/5. 4/5 is already written as a fraction, so it's obviously a rational number. So any number that can be written in a fraction is called a rational number. Now, any number that cannot be written as a fraction is called an irrational number. So here are two examples. You may have come across them. If you haven't, you certainly will come across them in the next couple of years. The first example is a number called pi. It has this funny looking symbol and it's spelled pi. And it's about 3.1415926 and so on. Now nobody's found a way to write this as a fraction, so it's called an irrational number. Another example is the square root of 2. This is 1.414213 and so on. And again, we cannot write this as a fraction. So both of these are examples of irrational numbers. Right, a real number. Well, basically a real number is everything I've just been chatting about. A counting number, a whole number, an integer, a rational, or an irrational number. They are all real numbers. Right, let's quickly chat about this word infinity. Infinity is a symbol used to describe the end of the counting spectrum. Now in real life, there is no end, because if I get up to a really large number, you're just going to add 1 and go 1 further than me. So technically there is no end to counting, but we use it basically to describe a very, very large number. Now if we're counting in the positive direction, we go to positive infinity. If we're counting in the negative direction, we count to negative infinity. The symbol used is this sort of sideways 8. Right, well, there are other numbers that include complex numbers, transcendental numbers, imaginary numbers, hypercomplex numbers. These are some examples. There's a lot more types of numbers, but we're not going to come across these until our mathematics is a very high level. Right, let's finish off with two quick things. You should know about these by now. An even number, basically an even number is a number that can be divided by 2 with no remainder, and they must end in either 2, 4, 6, 8, or 0. Okay, here's some examples of even numbers. And an odd number. An odd number is a number that cannot be divided by 2 with no remainder, and they must finish with either 1, 3, 5, 7, or 9. And here are some examples of some odd numbers. All right, thank you very much for watching our first video.